Welcome to this Annif tutorial video. In the following, we will learn about ensembles. When evaluating algorithms for automated subject indexing, you may notice that they make some silly mistakes. This may be due to several reasons. It could be simply errors in your training data, or you could have a lot of documents in one area, for example computer science, but only little on music. This is called skew and may lead the algorithm to prefer concepts that are related to computer science. It could also be the case that the concept is often assigned when there is a set of specific words present in the input. However, this assignment may not always be correct. You also have to consider homonyms. Rock could either be a stone or a style of music. Same goes for names, where Smith could also be a profession. Finally, random noise may impact the predictions. Let's make an analogy. Consider these three musicians. One has a broken instrument, the second misses some beats, and the last one plays out of tune, so their individual performances may not be very enjoyable. By having them play at the same time and under the supervision of a conductor, their playing will improve and the flaws may be less obvious. This is transferable to automated subject indexing. As in music, combining multiple algorithms is called an ensemble. The idea is to retain the individual strengths while reducing the weaknesses. In Annif, there are three ensemble backends available. The first one works by averaging the scores of the individual algorithms. Then there's the PAV ensemble. It applies isotonic regression to estimate the relationship between the individual scores and the actual relevance of a subject. It has to be trained using annotated data. Finally, the neural network ensemble. It starts off like the simple averaging ensemble, but fine-tunes the scores based on training data. It can also be trained incrementally. This means if you obtain additional data in the future, you may be able to further improve your results. Let's have a look at how we can configure a simple ensemble project. First, open your project configuration file. Here we have two projects configured. The first one is a TF-IDF project and the second one a MAUI project. We now add the Ensemble backend. Again, we have to give a name. Set the language. Define the vocabulary. And the name of the backend. Then we can continue with the Ensemble-specific configuration. We need the sources key and define that this ensemble will consist of the TF-IDF project, separated with a comma from the MAUI project. This configuration, as it is, will give equal weight to the TF-IDF and MAUI projects. We now weight them differently by adding colon 2. The MAUI project will have twice the weight as the TF-IDF project. Now exit the configuration file and save it. Now we will see what an ensemble can do for us. Type echo start quote history of salt prices in Germany, end quote. This is a made-up title for this example. We pipe this to Annif suggest stw-tf-idf En. Hit enter. In the result list, we'll see that salt is on the first place with score of 0.7. This is good. But in the second place, it references Mongolians, which is nowhere to be taken from this title. Instead, Germany is referenced as a region. This may be because there is some relationship between salt and Mongolian in our training corpus. Further down in the list, we see good subjects like pricing statistics, pricing strategy, price theory, and price. Let's have a look at what Maui suggests. Going back in the history of commands by pressing the up arrow, pressing the left arrow, and replacing TF-IDF with Maui. We see that Maui is able to extract all the words from the title. So now let's check the ensemble. Here you can see that Germany is now on the second place. So this is an improvement from the base TF-IDF backend. However, Mongolians is still there, albeit with a lower score. Nonetheless, it's still higher than the price. But in the end, the results are improved because at least now you have the correct region referenced. And if you would cut off the scores at 0.15, you would have at least 2 correct subjects. Now you have seen how an ensemble can improve the predictions of algorithms for automated subject indexing. Thank you for watching.